Before physics became a mathematical science, it began as a branch of philosophy. For much of human history, the study of nature, what we now call physics, was known simply as natural philosophy. It sought to answer some of the most fundamental questions about the world. What is matter? Why do objects move? What causes change in nature? The first thinker to construct a systematic theory of nature was Aristotle. Living in the 4th century BCE, Aristotle developed a comprehensive explanation of the physical universe that would dominate scientific thought for nearly 2000 years. His ideas shaped medieval science, influenced early modern philosophy, and provided the intellectual background against which the scientific revolution eventually emerged. To understand the philosophy of physics, we must begin with Aristotle's vision of nature. Aristotle lived in a world without telescopes, microscopes, or experimental laboratories. Knowledge about the universe came primarily from observation and reasoning. Unlike later physicists who sought universal mathematical laws, Aristotle approached nature as a qualitative system governed by purposes and intrinsic tendencies. In his work Physics, Aristotle defined the discipline as the study of natural things and their principle of change. Nature, for Aristotle, was not merely a collection of particles or forces, it was a dynamic system of substances striving toward their natural states. Everything in the universe had its own nature, and this nature determined how it behaved. Understanding physics meant understanding why things move and change according to their natural properties. One of Aristotle's most important philosophical contributions was his theory of 4 causes. He believed that fully explaining any natural phenomenon required answering 4 different types of questions. 1. Material cause, what something is made of. Formal cause, the structure or pattern that defines it. Efficient cause, the immediate source of change or motion. Final cause, the purpose or end toward which a thing moves. For Aristotle, explanation in science was not merely mechanical, it involved teleology, the idea that natural processes are directed toward goals. For example, a seed grows into a tree not simply because of chemical reactions, but because its nature aims towards the mature form of a plant. This idea of purpose in nature was central to Aristotelean physics. Aristotle divided motion into 2 fundamental categories: natural motion and violent motion. Natural motion occurs when objects move according to their inherent nature. For example, earth and water naturally move downward. Air and fire naturally move upward. These movements reflect the structure of the cosmos itself. According to Aristotle, the universe was composed of 4 terrestrial elements: earth, water, air, and fire. Each element had a natural place within the cosmic order. Heavy elements such as earth and water moved toward the center of the universe. Lighter elements such as air and fire moved upward away from the center. This explained why stones fall and flames rise. Motion, in Aristotle's view, was simply an object seeking its proper place in the cosmic hierarchy. Aristotle's physics was inseparable from his cosmology. He believed the Earth was stationary at the center of the universe. Surrounding the Earth were concentric spheres carrying the Moon, the Sun, the planet, and the stars. Unlike the imperfect world on Earth, the heavens were made from a perfect substance called ether. Celestial objects moved in perfect circles because circular motion was considered the most perfect form of movement. Thus Aristotle divided the universe into two regions. One, the terrestrial realm, characterized by change, decay, and irregular motion. Two, the celestial realm, characterized by perfect, eternal, circular motion. This cosmology formed the basis for the later Ptolemaic system, which dominated astronomy for centuries. One of the most important differences between Aristotelian physics and modern physics concerns the concept of force. In Aristotle's theory, motion requires a continuous cause. If something moved, something else had to be actively pushing or pulling it. This led Aristotle to conclude that objects would naturally come to rest unless acted upon. This idea contrasts sharply with the modern concept of inertia introduced much later by Isaac Newton. In Newtonian physics, motion continues indefinitely unless acted upon by an external force. For Aristotle, however, the rest was the natural state of most objects. Motion requires explanation. Aristotle's system endured for nearly 2 millennia. This was not simply because of philosophical authority. His framework has several advantages. First, it matched everyday observation. Objects fall down, flames rise upward, the earth appears stationary. Second, it provided a comprehensive worldview. Aristotle's physics was connected to metaphysics, biology, ethics, and cosmology. Third, it offered intelligible explanations. Rather than abstract equations, Aristotle explained nature in terms of purpose, form, and substance. For ancient and medieval thinkers, this made the world understandable in human terms. Despite its influence, Aristotelian physics contained fundamental limitations. It lacked quantitative methods. Unlike modern physics, Aristotle rarely used mathematics to describe motion. Instead, his explanations remained largely qualitative. Furthermore, many of his conclusions relied on intuitive reasoning rather than controlled experimentation. These weaknesses became increasingly apparent during the Renaissance. New observational tools and experimental methods began to challenge Aristotelian worldview. The thinker who initiated this transformation was Galileo Galilei. Through systematic experimentation and mathematical analysis, Galileo demonstrated that many Aristotelian assumptions about motion were incorrect. This marked the beginning of a new approach to physics. Aristotle's physics represents the first great attempt to understand nature systematically. Although many of his specific theories were later overturned, his philosophical influence remains profound. He introduced the idea that science must seek causal explanations. He emphasized that understanding nature requires identifying underlying principles. And he demonstrated that the study of the physical world is inseparable from deeper philosophical questions about causality, purpose, and change. The history of physics can therefore be seen as a dialogue with Aristotle. Later thinkers did not simply reject his ideas. They refined, challenged, and transformed them. The next major step in this transformation occurred during the scientific revolution, when philosophers and scientists began to argue that nature is written in the language of mathematics. In the next episode, we will explore how Galileo and the rise of mathematical physics reshaped our understanding of motion and laid the foundations for modern science.